All right, 8th graders, I am actually sitting in the lobby of a hotel right now, so I apologize for any background noise that might be distracting.
Like Mrs. Hillman. Hi, guys!
Like Mrs. Hillman right here. However, I am going to go over the last 3 proofs that's on your study guide because I know some of you were a little confused by some of them, and that's okay. So let me quickly go over them. You can obviously fast forward to any of these that you would like. So if we look at the given here in this problem, the given says that angle ABF, AFB is congruent to angle EFD, which have been marked. We want to prove that FB, the ray FB, bisects angle AFC. Now remember what a bisector says. A bisector states that we have 2 angles that are congruent. So we have to prove that these 2 angles are congruent. So let's first write down our given. So we have our given written. But now, if we need to prove these congruent, we have to figure out a way. Here's the problem. If you don't know what an angle bisector is, that's part of your rules, your definitions that we have to know. So we have to know that ray FB bisects this big angle into 2 congruent angles. Well, what do I know? From previous math, you know that these are vertical angles. So we know that they're congruent. So this angle here and this angle here are vertical angles. So I could say in step 2 that angle EFD is congruent to angle CFB because definition of vertical angles or vertical angles are congruent. Now we know that these are congruent right here. Now what do I know? Now there's a couple ways you could do this. Well, if I know that angle AFB is congruent to angle EFD, and EFD is congruent to angle CFB, then I know by transitive property that these 2 are equal. Now you could have also said that their measures are equal and then use substitution as well, which is perfectly fine. But then we know that angle AFB is congruent to angle BFC. And so in step 3, that's transitive property. If you change them by definition of congruent angles, if you said that they were equal, then you could say substitution. So now do we know that those 2 angles are congruent? Absolutely. So I can say that ray FB bisects angle AFC. And why? Because of definition of angle bisector. All right, so here's our next example. So let's look at what we have. I'm going to write down the given. So we know that these 2 lengths, and I've marked them in the picture already, lengths AB and CD are equal, and BC and DE are equal. Now, we have to prove that C is the midpoint of segment AE. So if you don't know what the definition of midpoint specifically says, then you don't know it well enough. So what do we know about the definition of midpoint? What does it say? It should say, or you should know, that it says that one piece is congruent to another. Definition of midpoint takes a segment and cuts it into 2 congruent pieces. So I have to somehow say that if C is the midpoint of AE, I have to say that AC is congruent to CE. Well, the first thing we have to do is we have to add segments together. So we're going to use the segment addition postulate, and we can say that AB plus BC equals AC, and I can say that CD plus DE equals CE. And that's the segment addition postulate. Now, from there, what do I know? So how do we get there? Well, look at our given. Our given, it gives us 2 things. It gives us AB is equal to CD and BC is equal to DE. So if I had a B and CD, I can add anything I want to both sides. It's like saying if you had, I'm just making this up, but you could have x equals 2. I could add 4 to the left side, I could add 4 to the right side, as long as both things are equal. The same thing is true with A, B, and CD. I could add B, C, and D, E to both sides because they're equal. So I could actually say that AB equals CD, that's what we currently have, and I could add the same value to both sides. Well, the same value is BC and DE, so I could just add BC and DE to both sides because they're the same thing. And that is the addition property of equality. Now from there, what do I know? Well, it says here AB plus BC, and here I have AB plus BC. Well, what is AB plus BC? It's the length of AC. So I can say by substitution that if I plug in AC, and over here I plug in CE, I can say by substitution that they're equal. But now I have to go to the definition of midpoint, which says two pieces are congruent. So now I have to say that segment AC is congruent to segment CE by definition of congruent segments. And then in the last step, because I now know they're congruent, I can say that C is the midpoint, and why? Because of definition of a midpoint. Now you could also have just said, remember once again, that the definitions you can always say as well. You can say a midpoint cuts a segment into two congruent pieces. Definition of congruent segments, you could have said equal segments. The lengths are, if their lengths are equal, then their segments are congruent. Either one would work. Okay, in our last example, I've already written down our given, but let's look at it. We know that this angle here, which is marked in the picture, and this angle here are right angles. We have to prove, and the angle 2 is congruent to angle 3. We have to prove that angle 1 and 4 are congruent. So in my mind, this is what I'm going to think. I know the big angles are congruent, or are right angles, which we're going to have to lead into saying they're congruent. Then I know parts of them are congruent. Well, wait a minute, what do we know? We know that these are going to be complementary, right? So if I have congruent angles, and then I can prove that these are complementary, then I can use the complementary supplements theorem to prove angle 1 and 4 are congruent. So that's the process. Unfortunately, I can't teach you. That's just trial and error and practice. You're going to have to go through and know these definitions well enough that you can kind of develop your own plan. So example number 2, or problem number 2. We know that they're right angles. Well, if they're right angles, what do we know about them? We know they're congruent. So I can say angle KLM is congruent to angle NML. Why? The right angles theorem. The best way to say is right angles are congruent. There we go. We know they're congruent. Now, step 3. If I know that they're congruent, what do I know about their measures? I know that their measures are equal. And I apologize once again that my writing is not the best. My stylus just broke, and I'm sitting in the hotel lobby. And so we know that we have definition of congruent angles. Why? Because congruent angles are equal. All right, everyone, say thank you to Mrs. Hillman. She just got me a new stylus here. Ooh, this one works nice. Ooh, look at that. Much better than my handwriting. All right, so now we know that their measures are equal. And why do we want to know that? Because the next step is proving that the measures added together will be complementary, which is one way you could do it. You could do it like that. So, and actually, you know what? We're going to do this 2 separate ways. We know that their measures are now equal. I'm now going to use the angle addition postulate, and I'm just going to add them up. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle KLM. And then I'm going to do the same thing for the other side. The measure of angle 3 plus the measure of angle 4 equals the measure of angle LMN. And this is the angle addition postulate. Now, this is the wonderful part. Look at our given. Right here. Angle 2 and angle 3 are congruent. if I say that they're equal, the measure of angle 2 is equal to the measure of angle 3, once again, congruent angles are equal, or definition of congruent angles. Now from there, watch what I can do. Right here, I know that these two angles are equal. If these are equal, I can substitute them into each other. So in step 6, I can say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 4. And that would give me substitution. Now, I know the measure of angle 2 equals the measure of angle 3, so I'm just going to plug it in. So I could say in step 7, the measure of angle 1 plus the measure of angle 3, I just plugged it in, equals the measure of angle 3 plus the measure of angle 4. And what did I do? I once again used substitution. Now, here's the weird part. This is the weird part. Would you agree that these are the same thing? Yes, they're the same thing. And so I could subtract them off both sides. But I haven't said that the measure of angle 3 is equal to itself. So we're going to say the measure of angle 3 equals the measure of angle 3, and that's the reflexive property. Now, anytime you have to subtract something, you have to first say that it is equal to itself. And it's the reflexive property. Up here, like we said, they're equal. Here we said they're equal, so we substituted them in. We say they're equal, and now that we say they're equal, we can use subtraction property of equality to subtract the measure of angle 3 on both sides. So I can do the measure of angle 1 equals the measure of angle 4. And that's going to be the subtraction property of equality. And now I know the measures are equal. I can say my final step, which means the angles are equal. I'm sorry, the angles are congruent. And once again, equal angles are congruent, and that is definition of congruent angles. Now, what's the other way you could have done this? You could have said, as I said in the beginning, that you could have said angle 1 and angle 2 are complementary. Angle 3 and angle 4 are complementary. Because we first would have to say they're 90 degrees. So you would say that they're right angles. Then you would say because they're right angles, definition of right angles says their measures are 90 degrees. You'd then say angle 1 and angle 2 are complementary, angle 3 and angle 4 are complementary. By the given, angle 2 and angle 3 are congruent, and if they're complementary, you could say the congruent complements theorem and prove that angle 1 and 4 are congruent. That would also be an acceptable way to solve this proof.